So for ethanoic acid, pKa is there. So from pKa, we can find the dissociation constant. How to find a dissociation constant? Ka. It's the same thing. Look, pH is equals to minus log of hydrogen ion concentration. So pKa is equals to minus log of Ka. So if we need Ka, so 10 raised to power minus pK, like as we used to do 10 raised to power minus pH is equals to hydrogen ion concentration. So 10 raised to power minus pKa is equals to Ka, dissociation constant. So 10 raised to power minus 10 raised to power minus 4.76 will give us the value for Ka. And after getting the value for Ka, ethanoic acid is a weak acid. So example, if we have ethanoic acid, so CH3COH, it will dissociate into CH3COO plus H plus. If original concentration is 1 into 10 to the power minus 10, initially it is 0 because acids does not dissociate initially. When we mix them, say X moles of acid, S moles of hydrogen ion, and this will be 1 into 10 to the power minus 10 minus X. So 1 into 10 to the power minus 10 and minus X. But so when we write K, K is a product divided by reactant. So K is equals to concentration of CH3CO, concentration of hydrogen ion, and divided by concentration of acid CH3COH. So K is given 10 to the power minus 4.76. We calculated the concentration of the acid, acetate ion X, the concentration of hydrogen ion also X, and this is 1 into 10 to the power minus 10 minus X. But we neglect X because X is very small. We normally in a calculation we neglect. So this will become 10 to the power minus 4.76 is equals to X squared divided by 1 into 10 to the power minus 10. So this 1 into 10 to the power minus 10 is divided, other side it will be multiplied. So 1 into 10 to the power minus 10 multiplied by 10 exponent minus 4.76. Take a root, this will give you the concentration of hydrogen ion. And from concentration of the hydrogen ion, after getting the concentration of hydrogen ion, we'll use the formula that pH is equals to minus log of hydrogen ion. Like from this equation, we'll get the value of X. And from value of X is actually equal to hydrogen ion concentration. We'll get the pH. So it will come out as 7. So 7 will be the pH of this solution. Then what type of stereoisomerism will be shown by a compound with a structure? To show a geometrical isomer, we have to check the carbon which is having a double bond should have different groups attached to it. If different groups are attached, it will show a geometrical isomer. So it will be, as you can see, these are the carbon which are having a double bond. So this carbon attaches CH3 and here CH2 and CH3. And here is hydrogen and then this is CH3, and so different groups are attached to a carbon. So it means it will be geometrical. But whether it is optical, how to know optical? To be an optical isomer, there should be a chiral carbon. What is the meaning of chiral carbon? Means all the bonds of the carbon should be different. Like all the atoms, all the bonds of a carbon should be different. So when I check this carbon, this cannot be chiral because it is having CH3. So 3 hydrogen are there. When I check this one, this is also CH3, 3 hydrogen, not a chiral. This is CH2, not a chiral. This one is CH, it cannot double. Why it cannot be a chiral? Because double bond is there between the 2 carbon atoms. So like 2 bonds between the atoms, that's why it cannot be chiral. To be a chiral carbon or to show an optical isomer, there should be different groups attached. So the carbon-carbon double bond cannot be a chiral carbon, impossible. When we check this one, so three bonds are there. This is CH3, this is CH3, this is H. But the problem, this cannot be a chiral. Why? Because two identical groups are attached. Like carbon, this carbon, when I take this carbon, it should be different bond, but here it is CH3, here also CH3. So it cannot be a chiral. And these two carbon can never be chiral because three hydrogen and three hydrogen. So there is no chiral, so it does not exhibit any optical isomerism. It only exhibits geometrical isomers because two different groups are attached to carbon atoms. And double bond is there which restrict the rotation. Is it clear? Discussion 14. Some of the physical properties of aldehyde and ketones are explained by the fact that they, aldehyde and ketone, aldehyde is C double bonded with O and H, and ketone is C double bonded with O. So never form hydrogen bond, that is wrong because there is oxygen involved here. So some of these aldehyde and ketone can form hydrogen bond. So this is not correct. Form hydrogen bond in a liquid state, but not in aqueous. Though they do, that is opposite. Because when they are in a liquid, because between the two molecules, like between the two aldehyde molecules, they don't tend to form the hydrogen bond. Hydrogen bond is formed only when water is there. So in aqua, like example, if I have say ethanol. So ethanol is there. This is one molecule of ethanol, and then this is another molecule of ethanol. So these molecules, because to form a hydrogen bond, hydrogen must be attached directly with the most electronegative element, such as nitrogen, oxygen, or fluorine. But in these examples, hydrogen is not directly attached to any of these. So they will have an interaction, but they cannot have a hydrogen bond between them. But if there is a water molecule, like example H2O, so oxygen is having a lone pair, so there will be partial positive and negative, and this hydrogen will be attracted toward the lone pair of the oxygen. That is called a hydrogen bond. So when they are mixed with water, they can form a hydrogen bond with water molecule, but between themselves, they cannot form a hydrogen bond. That's why C is the right answer. Then which correctly shows the reaction of ethanol and propanol. Ethanol is an aldehyde with toluene reagent. It can react. 2,4-dinitrophenyl is a test for aldehyde and ketone, both of them. If there's an aldehyde or a ketone, this will give a positive result. But this toluene reagent or Fehling or Benedict, toluene reagent is like silver mirror test, and Fehling and Benedict solution is like a copper 2 ion is there. So that is only valid for aldehydes, but it cannot occur for ketone. So this is only react for aldehyde, but this is for both. So that's why D is the right answer. So this is like toluene reagent or aldehyde ketone can be distinguished by using a toluene reagent or Benedict solution as well. In question 17, under suitable conditions, butanoic acid, if you have a butanoic acid, so react with acidified potassium dichromate to form butanol. So when we check the option, why A is not correct? Because butanoic acid cannot be oxidized. Because this potassium dichromate is an oxidizing agent, but acid cannot be oxidized, acid can be reduced. So that's why A is not the right answer. React with phosphorus 5 chloride to form 1 chloro. Why B is not correct? Because butanoic acid react with PCl5, but the chlorobutane is not the product. It will form acyl chloride. How it will form acyl chloride? Look, butanoic acid is what? Butanoic acid is like CH3, CH2, CH2, C double bonded with O and OH. That is butanoic acid. When we add PCl5, phosphorus pentchloride, chlorine will take position of a hydrogen. What will be the product? So the product will be acyl chloride, C double bonded with O and Cl, plus POCl3, sorry, C double bonded with O and Cl, not OCl, C double bonded with O and Cl, acyl chloride, plus POCl3 plus hydrogen is also removed with one of the combined, so it will give HCl. So they mention if it react with phosphorus 5 chloride, it will form chlorobutane. It does not form chlorobutane. It will form ethonyl chloride, not simple halogen alkane. If it was like alcohol was there, then it will produce chloro. So why B cannot be an answer? Because it does not form chloroalkane. It will produce ethonyl chloride or ethonyl substance. Then when we check option C, C is not correct because acid product when butyl methanoate is hydrolyzed in methanoic acid. So if we hydrolyze this, the first name of the ester give alcohol, so it will be butanol. And the second name is methanoic acid. So butanoic acid is not formed, it formed butanol because the first part is coming from for ester is coming from alcohol forming an alcohol, and the second part is acid. And then forms butanoic acid form butane nitrile when we react with hydrochloric acid. So that is true because this butanoic acid can convert into hydrogen cyanide when it reacts with acid. So D is the right answer. Is it clear, this question? In this question is about the following compound: ethyl ethanoate, methyl propanoate, propyl methanoate, and butanoic acid. Which of these compounds are isomers? Look, how to identify the isomers. They should have the same molecular formula but different structure to be an isomer of each other. So when I write the formula for ethyl ethanoate, so it will be C double bonded with O and O. Then this is C2H5 and this one is CH3. So the molecular formula of ethyl ethanoate, 4 carbon and 8 hydrogen and 2 oxygen. Methyl propanoate, so C double bonded with O and O, methyl, this is CH3, and propanoate, prop means 3 carbon. So this will be CH2 and this is CH3. So C4, H3, 8, NO. So it means first two are isomers. Propyl methanoate, it is the same thing. One side is a propyl, means like here it is C3H7, and here we have H. So it becomes C4H8NO. So that is also isomer. Then butanoic acid, but means four carbon C, like, so this will be C3H7 COOH. So 4 carbon, 8 hydrogen and 2 oxygen. So all are all have the same molecular formula but different structure. So all the 4 compounds, above 4 compounds, are isomers of each other. Is it clear? Discussion? Then the last one. So ethane 1,2-diol form a polymer with a benzene 1,4-dicarboxylic acid. So look, this is ethane 1,2-diol, and the other one is a benzene 1,4-dicarboxylic acid. So benzene ring is there. Benzene ring, if you want to write in a formula, benzene ring is C6H5. H4 will be there because, and both sides there's a carboxylic group, C double bonded with O and OH. And here also C double bonded with O and OH. Now, remember how a condensation polymer is formed? So one side, if we have a diol and dicarboxylic acid, so one side we remove H, other side we should remove OH. So you see all of them are starting with O, so it means the first we'll remove H, so that all started with O, and the other side will remove OH. And then we'll remove H, and the other side will remove OH. So what will be the structure? It will be O, or one thing, because so if one side I remove, here H I remove, so it will be O CH2. This CH2 is there. Other side OH is removed and H is removed, so there will be O. This O will be there, and then C double bonded with O. Then C4H9, C6, sorry, C6H4, and then C double bonded with O. So which one it matches with? So this is O and CO, O, CH2, CH2, O, and then, yeah, that's right. So A is the right answer because it matches with, when I simplify A, it will be like CH2, CH2, OO, C, C6H4, and CO. So it matches with option A. Is it clear, this one? So whenever you have dicarboxylic acid and diol, one side you remove H and another side you will remove OH. So this was January 2018, Unit 4.